Okay, in this video, we are going to go over two topics, and they're both pretty quick. Molarity and dilution. So molarity of a solution and a dilution. So molarity itself is representative of the number of moles of solute per liter of solvent. Remember that in any solution, the solute is what's present in the lesser amount, and the solvent is what's present in the larger or greater amount. And in a solution, your solute and your solvent may initially not be in the same physical state, but when they become a single solution, they do arrive at the same physical state. And when we're calculating molarity, it's important to realize that we are calculating in moles and liters, not grams and milliliters. So those conversions are going to be things that are going to have to occur before you calculate for molarity. Your formula for molarity is equal to moles over liters. Molarity is represented by the capital letter M. And you can also rearrange the formula to solve for moles, which would allow you to therefore then also solve for grams and volume. It's just like any other three variable equation, kind of similar to what we saw with the density formula. So if I wanted to solve for moles, I would multiply across by my liters. So liters times molarity would equal moles. And if I wanted to then solve for liters, I could divide my moles by my molarity to solve for liters. So I need to be able to manipulate my three variable equation. All right, so we're just going to jump right in because these are, I said, pretty easy. So number one, what is the molarity of a solution formed by adding 15 grams of carbonic acid to 125 milliliters of water? So two things here. I'm asked to solve for molarity, which is my capital M. I know to solve for molarity, I need moles and liters, and I'm given grams and milliliters. So neither of the two things that I actually need. But I have the skills to be able to get both of those things. So first, let's deal with our grams. I've got carbonic acid. So to get the molar mass in order to solve for moles, I need the formula for carbonic acid. So H2CO3, and then calculate the molar mass of that. So 2 hydrogens, 3 oxygens, and 1 carbon. My molar mass is 62.026 grams per mole. All right, so to get from grams to moles, I know that means I'm going to divide by the molar mass. So I'm going to take my 15.0 grams times 1 mole over the molar mass, which is 62.026 grams. My grams cancel. It's going to put me in moles. And this is going to come out to 0.24183 ... I'm going to keep the whole number in my calculator because this is not my final answer and I don't want to Sig Fig too early and then throw off my final answer. So I'm just going to ... and use the whole number. And then in terms of my milliliters, 125.0 milliliters, there are 1,000 milliliters in 1 liter. So 1 liter over 1,000 milliliters. My milliliters cancel, leave me in liters. And really all I'm doing here is moving my decimal 3 places to the left. So 0.1250 liters. All right. And now I have my two appropriate parts. Molarity is equal to moles, 0.24183. Remember, I'm using the whole number in my calculator, divided by the liters, 0.1250 liters, and that'll give me my molarity. I look back at my original values to check my Sig Figs. I had 3 here and 4 there, so I'm going to have 3, and this is going to come out to be 1.93 molar, and then my substance is the carbonic acid, H2CO3 AQ. All right. So again, nothing about the math here is hard. You just have to make sure that you've done your appropriate conversions prior to plugging in. And then at that point, it's very easy. All right, so let's look at number 2. How many grams of sodium hydroxide are required to form a 6.0 molar solution with a volume of 500 liters? So it's asking me to solve for grams, but I know with my formula, I can't solve for grams directly, but I can absolutely solve for moles, and I can use moles to get grams. So let's do that. So molarity is equal to moles over liters. multiplying across, liters times molarity gives me moles. So my liters here, 500 liters times my molarity, which is 6.0. So 500 times 6 is going to give me 3,000 moles. Okay. And then I need to get grams. Well, to get grams, I know I need my molar mass. So sodium hydroxide, NaOH, has a molar mass of 39.998 grams. So 3,000 moles times 39.998 grams over 1 mole is going to give me my grams. And let's see, 2 sig figs, right? Yeah, 6.0 has 2 sig figs. So this comes out to 119,994 to 2 sig figs. That'd be 120,000 grams of NaOH. All right. So we've solved for molarity, we've solved for moles, which then got us grams. So it seems logical that our last example would be solving for liters. And in fact, that's what it is. So how many liters of water are needed to dissolve 13.7 grams of C6H12O6 to make a 2.0 molar solution? So again, I've been given grams and I have a molarity and I need to get liters. And because I'm going to have to get the liters out of this molarity value, I have to convert this to moles in order to do that. So my molar mass of my glucose is 180.156 grams per mole. So I can use that to dive in here and get my moles. So 13.7 grams times 1 mole over 180.156 grams is going to give me my moles. And that comes out to be 0.07604 and change. We're going to keep that whole value. All right, so how do I get liters out of this? Well, we need to rearrange our formula. Molarity is moles over liters, and we know multiplying across, liters times molarity is moles, and then dividing by molarity, liters equals moles over molarity. So I have my moles, and I have my molarity, and I'm just going to put that right underneath there. So my moles, the whole number in my calculator divided by molarity, 2.0 is my Sig Fig indicator here, so 0.038 liters of H2O, because that's what it's asking me, how many liters of water. All right, so there's one example for each variable. The next thing we're going to do is look at dilution. So dilution is where we reduce the concentration of a solution by increasing its total volume. Okay, and our formula for this is M1 V1 equals M2 V2. We'll consider what we know about our molarity formula up here. When I had liters, which is volumes times molarity, that was equivalent to moles. So really what this is saying down here is molarity times volume equals molarity times volume, which is really just moles have to equal moles. So what we're doing in a dilution is we're taking a small amount of something very concentrated and we're adding a bunch of water to it to dilute it. But the number of moles of the solute doesn't change. I just spread those moles out over a greater volume. So the relationship that the moles I have at the beginning and the moles I have at the end don't change in my formula. And then the other thing it's important to note is that this is actually a really commonly used lab technique. In fact, anytime I make solutions for class, this is what I will use because it's much more cost effective to buy a small amount of something very concentrated and make the various solutions that I need than ordering all of those individual solutions. And so because I'm doing this in the lab, a lot of times I'm measuring in milliliters because milliliters is just what my lab equipment is commonly broken up into. And so because I'm not actually breaking down the molarity unit itself, it's perfectly appropriate to use milliliters here. The only time you wouldn't want to use milliliters is if you had two different volumes and they were in different units. One was liters, one was milliliters. You would have to make them the same to do these calculations. But other than that, if it's given to you in milliliters, you can roll with it in milliliters. It's just fine. All right, so let's do these 3 examples here real quick. To what volume should 45 milliliters of a 15 molar sulfurous acid solution be diluted to prepare a 3 molar solution? So logically think about what we have here. We have a pretty small sample, 45 mils of a really strong acid, and we're going to make a significantly weaker acid. So in terms of what's going to happen here, it should make sense that if I'm going from 15 molar to 3 molar, I'm going to be really increasing my volume to compensate. So the only thing you really have to watch when you're doing these is make sure you pair your parts correctly. The 45 obviously goes with the 15, and it doesn't matter if you put those as M1 and V1 or if you put them as N2 and V2. They just have to be together. So 45 milliliters times 15 molar is equal to 3.00 molar V2. So really what I'm doing, I'm going to take 45 times 15, I'm going to divide it by 3 molar, and that's going to give me my V2. When I calculate that, that gives me a V2 equal to 225. Then considering my Sig Figs, it looks like I can keep 2. Yeah, 2. So this is going to be 230 milliliters of sulfurous acid, H2SO3AQ. So I'm going to take my 45 milliliters of the 15 molar. I'm going to put it inside a vessel. I'm going to add water until the total volume reaches 230, and that would be my new solution. All right, so that's our first example. Let's look at another example. What is the molarity of a solution formed by diluting 75 milliliters of 12 molar hydrochloric acid, or HClAQ, to a volume of 500 milliliters? So now this time I'm given 2 volumes on only 1 molarity, so I'm finding the missing molarity. Notice I'm taking 75 mils of 12 molar and I'm making it 500 mils. So it should make sense that because I'm going to be adding just a ton of water here, that my molarity is going to go down. All right, the 75 and the 12 go together. So 12 times 75 is equal to M2 times 500. So 12 times 75 divided by the 500 is what we're going to end up having. And that comes out to 2 Sig Figs to be M2 equal to 1.8 molar HCl. And so what we thought would happen with the strength of our acid reducing did in fact happen, which makes sense. I added a ton of water to a pretty small sample, so it should have gone down. All right, so the last one here, number 3, this is the only one that actually kind of requires you to think a little bit. Number 3 says, to how much water should 50.0 liters of a 10 molar HCl be added to prepare a 4 molar solution? So if you compare this to number 1, in number 1 it said what volume should 45 mils of a 15 molar sulfurous acid be diluted? This one I just want to know how much water. So in number 1, I found total volume. In this one, the total volume is not my final answer. The difference between my initial volume and my final volume is the answer, because I want to know how much water I added to get there, not what the final volume would be. So stepwise, it's the same to begin with. The 50 and the 10 go together. So 50.0 and 10 equal V2 times 4.0. So I'm going to divide by 4.0. The thing that you have to watch here is what happens with your Sig Figs. When you multiply this, your calculator wants to cut you off a decimal, because 50 times 10 is obviously going to give you 500, but it's 50.0. So it's actually 500.0. And because we are going to subtract, that makes a difference. So just make sure that you're paying attention, that if you have a decimal place, when you go to do the subtraction, you maintain that decimal place. So 50 times 100 divided by 4 is going to give me a V2 of 125.0, which is my total volume. I want to know how much water I added to get to the total volume. So considering that my initial volume was 50 liters, I added 75.0 liters of water. Okay. All right, so that's pretty much everything you're going to see in this unit. Message me if you have any questions.